All right. So we're on to our third and final paper. It's called Implementing an AI Teaching Assistant for a Class in Motion Picture Engineering and presented by Deirdre O'Regan. Deirdre is a postdoctoral researcher with SIG Media Group, Department of Electronic and Electrical Engineering at Trinity College Dublin, where she completed her PhD in 2010. All right, come on up. Did I have to answer? Yeah, okay. Hi, sorry. It's a little calibration there. Yeah, thanks for having me. So, the class in motion picture engineering is a master's level engineering course in Trinity College Dublin, where I hail from. And it's actually been being delivered since 2015. And it's quite a nice, unique course in that it covers core principles of video processing, such as compositing and segmentation, and video streaming, alongside addressing the latest advances in the field, like the influence of neural nets in the field. Students are required to undertake assignments and learnings in advanced math and coding. They get practical training in Nuke software by the Foundry, including building graphs and also writing Blink script code, which is the coding language there in Nuke. And they're treated to a variety of talks from industry guest speakers from the likes of YouTube, Netflix, and we actually have one industry guest speaker who gave a talk to us in the room, Carrie's, who gave a very wonderful talk representing Sky. So it's a great course, but the annual challenge that we always have is that this course attracts a very diverse set of students with different backgrounds and technical experience levels. So some of them may have had some experience with signal processing, image processing. Some may have had some experience with neural nets, deep learning. Some may have had experience with both, and some may have had experience with neither. So it's always difficult to know how to provide adequate support for all the students, as well as ensuring that everybody is entertained and challenged. So we thought that we might explore how LLMs could help us with this by creating an AI teaching assistant for motion picture engineering. So I'm going to tell you about how that went. When you start to look into what other educators have done for this, the concept of retrieval augmented generation, or RAG, seems to be the way to go. So just to explain RAG, maybe some people know about it already, but just in case, it combines search technology with querying an LLM together to for good things. So essentially the user queries, it's particularly useful if you have kind of like knowledge base full of materials that you want to sort of combine with an LLM's answers. In our case, it would be the course materials for motion picture engineering. So the user queries, and the first thing that happens is there's a search over the knowledge base, and bits of relevant context are pulled out of that, and then those bits of context are combined with the user's query to prompt the LLM, and then the LLM's answers should answer with more grounded responses that are more suitable to the content, and also it's purported to mitigate or reduce even hallucinations. So it's a well-established paradigm. It has broader applications than just in the classroom. Obviously, anywhere where you have a specialized knowledge base and you want to train people on it or let them query it using natural language, you can apply this too. So as I said, RAG is a well-established paradigm. There's lots of papers out there about improvements to the actual RAG technology and algorithms and so on. Our paper is more about a practical use case on the constraints and challenges of RAG implementation for something like an AI teaching assistant and its integration into a real world environment like a classroom. And in our case, we did this for our MPE course. Our teaching assistant had the constraints that, number one, we were in a university setting, so we had to use institutionally approved technologies or else face going through, how do you say, when you get your software checks for compliance and all of that. We didn't want to have to do that. If we could not to. We wanted to give the students anonymous access to the teaching assistant so that they wouldn't feel coerced to use it. Like we told them it wouldn't affect their grades if they used it or not, or abandoned it. So it's important we didn't know who was and who wasn't. In case of any students entering private data into the conversations with the teaching assistant. We wanted that data to be protected. Also, a solution that had AI safeguards, complied with local regulations such as the European Union's General Data Protection Regulation, which we are subject to in Ireland. Be deployed securely on our college network, so it didn't bring the network down. And also, have the ability to be able to customize it. For example, if we saw some specific feature that we could add for motion picture engineering specifically, because there are a lot of kind of plug and play RAG systems that are already out there that you could use, but you'd be constrained then by the product roadmaps of these kind of commercially available solutions. So we decided to roll our own, essentially, a custom build using on Microsoft Azure, which was the university's preferred enterprise software platform already. So that's kind of mostly why we chose Azure. It was going to be compliant and everything. Azure also has this platform called Azure AI Foundry, which has a lot of tools and things for building custom AI solutions. So that was also good. And very important to us was Azure has this license. Maybe some of you know this already, but it was important to our implementation with OpenAI, where they actually retain copies of OpenAI's model weights inside the Azure boundary, and they kind of manage them themselves. So that meant that if we use those models, we could better comply with the GDPR because we could deploy them where we liked in the world, as Azure often lets you do with solutions. And also they have a customer guarantee that they won't use that data that hits the models for retraining the model. So this was our kind of technology stack that we chose. The first thing to do then was to explore this tool that Azure AI Foundry provides called Azure Prompt Flow. And it's kind of an abstraction that helps users to build these sort of multi-step AI solutions and deploy them as a service. It's a bit like LangChain or something like that, if anybody knows LangChain. So this is the architecture of our prompt flow. And being in the Azure environment, of course, it allows integration with all kinds of other Azure services if you want. So we used for the search over our knowledge base, Azure AI Search, which has allowed us to do some pretty powerful things such as hybrid search. So when when the student enters their query, not only will there be a keyword search over the knowledge base of course materials, but also a vector-based search based on embedding with a neural model. And we used one of the Azure OpenAI ones there for that. What else should I say? Yeah, the LLM that we used as part of the solution in our prompt flow was GPT-4o Mini. We also had some custom processing steps which were kind of specific to our use case. So, for example, students might ask the teaching assistant, when is my next test? So we had to have a piece where we grabbed the current date and time at the time of that query so that there could be logic in the prompt for the LLM such that it could work out if it was looking forward in time or backwards. And if they said, is it next week, it could answer properly. So then all of these parameters go into a prompt template, as you can see in the diagram. And the student gets their response from the LLM. As I said, you can, actually, I don't know if I said, you can deploy, prompt flows, as a kind of like a RAG as a service thing on an Azure virtual machine. And it has a RESTful endpoint. So then we could kind of like build a small client that interacted with that. And that was the user interface for the student. So it had a conventional chatbot UI, and the web app also, consumed the prompt flow, as I said, but stored session data and chat history in another Azure product SQL database, enabling it to remember kind of conversation history and stuff like that. So that's our kind of architecture and user workflow. A little bit about the prompt engineering. This seemed a bit like kind of a strange art to me. We found a paper, Principled Instructions Are All You Need, there at the bottom, which was helpful for understanding some principles about prompt engineering that you can try. And we incorporated some of them, such as role-based prompting, example-based prompting, audience integration and such. But if anybody here knows more about prompt engineering, I'd love to hear it, because it seems so strange. Our final prompt was 1,800 words long and had all kinds of clauses. For example, we tried to build in interaction guidelines that were geared at learning sort of efficiency or learning goodness, let's say. So if a student struggles with a concept, guide them step by step instead of just stating the answer. So that was important for us. As I mentioned, there was logic around date and time awareness, and then we used example-based prompting a lot for just formatting instructions. Because we made a nice sort of conventional UI for the teaching assistant, we figured that we were going to be competing for student engagement with the already established tools out there they were using, like ChatGPT and DeepSeek, which are so good now. So we thought there must be like a base level of features that we have to have here, or else they're just going to go straight to those. So we did things like mobile responsiveness in case they wanted to use it on their phone. Rendering math nicely, of course, which was important for the course materials, and a copy button for any code that came up so they could copy it and paste it into their code editors. So that's about that. So the administrator's workflow, so that before was kind of about the student's user experience. Now, what did the lecturer have to do to get all their course materials into the teaching assistant? So at this point, I'll say we focused on just a text-based teaching assistant instead of multimodal. Even though motion picture engineering is such a visual discipline, we wanted to do text-based for a first iteration. So the lecturer, after they deliver their lecture, or before, maybe, getting all their PowerPoint notes or slides and kind of other things that might be there, like assignment sheets or whatever, and getting them prepared to upload to Azure AI Foundry. And we noticed with motion picture engineering that some of the slides are very low context, like they could be just a formula or they could be just an image. So we recorded every lecture as well in motion picture engineering and then transcribed that into text. And so lecturer or a course administrator, teaching assistant administrator, could upload that to Azure to be included in the teaching assistant as the course went along. I'm not going to go through every step here, but you can see it's a very complicated, like high touch workflow for the administrator. And that we definitely saw as something that needed to be improved. Is there anything else I need to say there? I feel like there is, but I'll proceed. So we deployed the teaching assistant to our 43 motion picture engineering students exactly halfway through the course at week 7, and it was there for 7 weeks. And this graph showed what we could pull from the database in terms of the number of sessions they initiated with it per day, the number of queries that they asked it per day, and there was a not unexpected correlation between important course events such as when they had take-home assignments or graded labs and sort of small peaks in engagement. There's a major peak there, which is when we allowed them to use it as part of an open book exam, along with their printed notes that they're typically allowed to bring into an open book exam. So that's what that big peak is there. And even though the interaction with the teaching assistant is anonymous, we could deduce that most of the students actually used the teaching assistant during their exam. So there were 3 environmental conditions that we could compare the teaching assistant across in terms of open book exams. First exam occurred when we hadn't yet launched the teaching assistant, so students could just bring in their own printed notes to the exam. Second one is the one I just talked about, where we let them use it with printed notes. And the third one, we said, again, only printed notes are allowed, no teaching assistant. And amazingly, across all 3 of those exams, there was no significant exam performance difference for the individual students as a whole when we measured their grades. And that was encouraging because we actually specifically designed the second exam to be good for usage, knowing that the AI teaching assistant would be allowed there. So at the end of the course, we always give a course exit survey to find out about what students thought about it. And this time we asked about the teaching assistant too, and we posed 6 questions to the students. 5 were on the Likert scale answers, and that's what you see there. And the 6th was a more open-ended free text one, which I'll talk about in a minute. So this is just a summary of the 5 Likert scale questions, and you can see overall positive, it seems, sentiment towards having a teaching assistant. Especially if you look at question 3, which was where we asked them if they felt it enhanced their open book exam experience. So you can see that mostly strongly agree, and then a lot more agree too. So that seems really good. But then if you look at question 4, would they prefer it over a real tutor? There's some definite mixed feelings there, with most students saying sometimes, and some being actually quite negative about that. So this is really interesting to us, showing that the teaching assistant actually couldn't replace a real human tutor. Question 6 then, as I said, was more of an open-ended question. We specifically prompted them to tell us if they thought that it should be allowed in open book exams, and asked them did it help them understand any topics which are otherwise difficult to grasp, etc. And then from those answers, I should say at this point actually that not every student answered the survey. Only 37 out of the 43 of them actually answered the survey. And of those 37 answers, we classified question 6 manually into 4 sentiment categories: positive with reservations, neutral, and negative. And the most amazing thing actually was the appearance of this opinion about whether they thought it should be allowed in open book exams. So 26 of these responses talked about that, and amazingly only 46% of students thought that it should be allowed, which is weird because in the previous question 3 that I talked about, students were so positive about the experience of having it, and also we know that it didn't affect their performance. So it led us to think that while they appreciated maybe the novelty of having it for that exam, or they appreciate it in the moment, they're definitely more hesitant about the idea of the use of AI, the availability of AI in exam contexts and assessment contexts perhaps maybe as well. And they actually even in this question 6 proposed some sort of ways to mitigate, that we could mitigate the use of AI in further exams, such as by docking students' marks if they used it, or reducing the number of capping the number of queries that any given student could do, or if giving students more marks if they didn't use it at all. So that was kind of a very interesting and perplexing finding, since it seems kind of contradictory. So the other data that we wanted to analyze was the actual messages that the students were sending to the teaching assistant, because we hoped that it could help us to improve the course going forward, because it might highlight some kind of commonly misunderstood topics that the lecturer could do a better job of explaining, or we could add pieces into the course materials for. So instead of building a kind of a different sort of topic analysis platform, because I guess AI human conversational topic analysis is quite young, we decided to see what we could do with the embeddings that we already had for the student queries that we used in the RAG pipeline. So let's see if we could extract some topics from those. So for this, we tried clustering them in embedding space using a modified k-means algorithm. And then when we had our clusters, we again used our LLM deployment that we already had to take a look at the queries in each cluster and give the clusters a nice kind of human readable label. And we employed TSNE to be able to visualize the clusters in 3D. And that enabled this kind of nice Plotly diagram, interactive diagram that the educator or the course administrator can kind of look at and explore, look at what's in the different clusters and how the clusters relate to each other, and sort of see if that's helpful in kind of understanding what students might be interested in and what we might consider refining the course to be. So I'm just going to wait a minute until we go to another little part of this video. So sometimes student queries are like low context. So they could be in the middle of a conversation, and like instead of saying, they might just say to the teaching assistant, what do you mean by that? Or tell me more, or something like this. So that kind of thing obviously won't do well in clustering that doesn't take into account conversational history. So we built another little piece for the administrator. Great timing. Where they could kind of dig down into into the messages themselves. They could filter by cluster and look up individual messages and look at the query and sort of the context around it, the context and the conversation around it. So that'll be really helpful as well for us when we're looking into what students were asking questions about, and if the teaching assistant kind of answers the questions well or not. So I have some recommendations for anybody who's doing a RAG system, and especially in the context of education. One thing is when there were kind of like when there was low engagement points in our data, our kind of usage data, we wondered if we were actually losing the battle with ChatGPT or the likes for student engagement. And when we check some things that ChatGPT would generate for us in response to student queries that might happen or actual student queries, it actually does a really good job at a lot of things now. It's just getting really more powerful, even for very specialized topics. So it's hard to compete with those already established alternatives, but we found 2 use cases where teaching or RAG-based systems are actually really, really good. So that's when you have completely private information. In our case, it's something like the logistics of course delivery, like when's my next test, or if class is cancelled or something like that. Anything that the internet doesn't know, the RAG-based system is going to be useful for, or some very recent knowledge. So we had an assignment for students where they needed to use FFmpeg command line to do a bitrate ladder. That was one of their assignments, and write a report on it. And the FFmpeg syntax had changed very recently. And ChatGPT, it wasn't that recently, but ChatGPT just didn't know about the change, so it was wrong. Whereas our teaching assistant was right, because we had documented that in the lecture notes. So that was a good win. Trade-offs between institutional constraints and utility. So that kind of particularly applied to us with the constraints that we had, and especially the anonymity that we built into the system, because we couldn't really talk to students because we said that everything was anonymous and we wouldn't know who was using the teaching assistant or not. We couldn't really talk to the students openly in class about what it was doing well and what it wasn't doing well, how it could be improved, what they thought of it. But they may have appreciated the anonymity, because in our survey question 6, there was an indication that maybe it was a good place to put all your dumb questions that you didn't want to throw your hand up in class. So we started to think of the teaching assistant more as like a window into student thought, where they would be too embarrassed to ask them into class. So I think that's where the topic analysis piece for course adaptation idea came from. And another constraint we had was with our, we actually didn't build the multimodal capabilities because we would have needed to use a third-party model to do that. And we were just being very conscientious, so we decided to leave that. So that is a thing that has to be considered. We didn't really understand with the Azure solution how the cost was structured. We thought we would be trying to calculate how many tokens were used in the messages, but that was not the thing that dominated the cost of our solution in the end. It was more the fixed infrastructure costs of the different Azure parts, like the search engine or the VM that the prompt flow had to be deployed on. And because we didn't think about it so much in advance, we probably kind of over-provisioned those just in case. And we worked out with a cost of 39 cents per user per day, which was probably twice of what we needed to pay. So some advice is just to understand the cost structure a little bit better, I guess. Sounds obvious when I say it, but it was something that we'll do next time, and right-size deployments of anything in the solution, and that can be more predictable. So in conclusion, our paper presents a use case on practical challenges of RAG implementation, and ours is about teaching assistant. And this is just a summary again of the little experiments that we did, and especially the complex attitudes towards AI and assessment scenarios was very interesting outcome, although student feedback was otherwise positive. Future work will involve obviously integrating the multimodal capabilities. Maybe we will be less concerned about the third-party model, because when we looked at what was happening, actually students didn't enter a lot of private data into the teaching assistant. Maybe none at all, because I looked at a sample of them and there was nothing. So maybe once they're instructed, that's fine. We might extend, in fact, we will extend this kind of topic analysis piece to perhaps provide daily instructor recommendations so that we can have on-the-fly course adaptation. And further automate the administrative workflow, of course, because with AI, we want things to, take less time. But if there's so much stuff that the administrator here has to do, that's kind of not achieving that goal. And another great thing actually is that a student from our MPE class last year will take on the work to improve the teaching assistant for next year. And we'll also, disseminate it to some other courses in Trinity, which is really great because, we're, I guess, not only, teaching with AI, with the use of AI, but, in some way teaching about AI and doing this exercise. So I think that that's important. And I forgot to mention earlier that, we put our custom web app client code, which works specifically with the Azure things and the prompt flow, on GitHub if anybody wants to grab it and use it. The QR code there will lead you to that GitHub repo. So that is it. Thank you very much. And if you have any questions, you're happy to hear them.
Thank you. Really, really interesting work. All right. We have a bunch of questions.
Oh.
Yes. So in the incident where ChatGPT didn't know about the change in FFmpeg, were you able to analyze any student reports that indicated whether they had used the teacher assistant or ChatGPT?
Well, I actually didn't mark the assignment that was about the bitrate ladder, so I'm not sure which students passed it and failed it, or if any indeed failed it. I'm not sure. And then further to that, like which methods they used. But I think that probably what happened is if it didn't work, right, they would just ask a human TA or they'd go to the lecture and they'd eventually figure it out. But we just counted it as a win anyway because we liked that our teaching assistant was giving the right answer.
They got it eventually, hopefully. What were the guidelines you used to chunk content and why was chunking needed? What was the need to extract keywords as part of the lecturer content workflow?
Okay. Was that chunk content?
Chunk, yes.
Yeah. So in terms of guidelines, I'm not sure. Well, in terms of methodology, we accepted kind of Azure's standard implementation that they give you when you're using AI Foundry to build your prompt flow. And it had some specific things that I usually know. I think it's page-based chunking for stuff like PowerPoints. And then there's I actually put it in the paper, but I can't remember it now. It's a footnote in the paper exactly what that is. But there was no particular strategy from us. It was just to accept what Azure's default offering was in the hope that it was good. And then kind of further work when actually we want to do more assessment of the teaching assistant in our next iteration as well. That might come into changing the content chunking strategy. And then the second was about keywords. What was the need for keywords? No need, except that Azure AI Search could do it. And we wanted to put it in because we assumed it would be better than just going with a vector search or a keyword-only search. We wanted to have a hybrid one since that seemed to be better. And we also threw in semantic re-ranking, which is just a button that you push in Azure as well. And because I guess those who came before us had established that these things are better. But as I said, we need to do more work in our next iteration of assessing the answers and more fine-tuning for that. We did do a little bit of fine-tuning and parameter adjustment just before we launched the teaching assistant, but it wasn't enough to cover the full body of questions that we thought students could ask, or like all of everything you could get out of those course materials. So that's a definite thing we need to work more on in our next iteration.
Right. All right. One more question, I think. It's interesting there was no difference in performance since many people seem to think AI is cheating. Do you think there are conditions where class performance would improve with the TA? Like a harder class or something like that?
So again, I understand that it's interesting. But
so there was no difference in class performance.
Yeah.
Because a lot of people think if you use AI, you're going to cheat and exceed everyone. Do you think that there are classes or classroom situations where the performance would improve with the TA?
Yeah. So this was kind of, to do with the formatting of the exam, I think. So perhaps if you had something, the way our questions were constructed was sort of to deal with this. Perhaps if you had more sort of multiple choice questions with obvious answers that the teaching assistant would be able to do a calculation and it would be right, you know, that would be worse for presenting that as an exam where you could look up a teaching assistant. But some of the way we dealt with the questions was different. Actually, the lack of multimodal capabilities helped us in this. It was kind of accidental because there were image-based questions. So you couldn't just grab the image and put it into the teaching assistant. You had to, it wouldn't be able to see it. So you had to know something there. And then the other thing was, special type of question, which the lecturer came up with. The co-author on this paper, Anil Kokram, who isn't here today, which is, it goes, a teaching assistant has come up with the following answer. State one thing that it got right and one thing that it got wrong. So it's kind of like a difficult thing to put back into a teaching assistant because you believe the answer that you got out again. So yeah, this sort of like thoughtful assessment design we think was the key there. But there are definitely other studies where performance of things was improved by using teaching assistant. And also then assignment, looking at more long-term performance, was either improved or not improved with with letting students use a teaching assistant. It's something, I guess that we will do more research on because it's super interesting to think about that.
Yeah, it's really interesting to consider the implications on like documentation and training as well for the rest of people that are not in education. But really interesting stuff. Thank you so much, Deirdre.
Thank you very much.
Amazing. Well, thank you all for attending this session and to the authors and speakers for all your contributions. So please join us now for another coffee break. And then at 5 o'clock, we will resume with our final sessions of the day.